Good morning, ladies and gentlemen. I also would like to thank the organizer for the opportunity to speak here in Dublin. My name is Tomáš Mareček. I'm chairman of the board of Eustream. Eustream is a Slovak gas TSO. And because we are in a hardware section, I will talk about hardware. Eustream is a hardware company. We actually are a transitor of a gas on the territory of Slovakia. Physically, 5 parallel pipelines, 56 inches in diameter, 650 megawatts of installed power in 4 compressor stations connected to Ukraine, Czech Republic, Austria, and Hungary. And you may have heard of Eustream, especially last year, when we started under the supervision of European Commission. I have to say it's a pity that Klaus-Dieter Borchardt isn't here today with us, because he helped a lot with the reverse flow to Ukraine. We started the big reverse in 1 year's time, last September, and today, as Stefan said, the reverse flow capacity, combined capacity from Western Europe to Ukraine is 20 BCM, and out of these 20 BCM, 15 billion is through Slovakia. And if you look at the utilization, it is still running at almost 100% of the capacity, even if the Russian gas for Ukraine today is cheaper than buying gas at Western hubs. That's interesting. I've been told that I have only 12 minutes, but I have 15 slides, so I will have to run through the first half of the presentation relatively quickly, because the important slides are at the end. This is the overall overview of European plus Turkey gas consumption. The latest data, this is the picture of 2013. You can see that the overall consumption was 510 billion cubic meters, including Turkey. Last year, each and every country in EU reduced its gas consumption, specifically partially due to mild winter, but every single country in EU reduced gas consumption, and we end up like 10% with 10% lower consumption. There is one exception, and that is Turkey. Turkey is the only market which was growing, and that's why it's so important country for many big gas players and for the future. The sources are 3. Basically, Russia producing or supplying Europe with approximately 1/3 of its need. 1/3 comes from the indigenous production, especially Netherlands, UK, Germany, Italy, Romania. Then, as we heard yesterday, we have 100 BCM country, which is Norway. We can expect them to supply Europe for many decades to come. Then we have two countries in Africa, Libya and Algeria, which are sending both pipeline gas and LNG with a 6%, and LNG used to be the plug-in gas, the last gas that come to Europe. If you look at a close-up view on our region, on Central and East Europe, these are also the numbers for 2013. The annual consumption of V4 countries is around 40 BCM, out of which approximately 8 is domestically produced in the region, thanks to especially Poland. So the import need of this V4 region is slightly more than 30 BCM annually. If you look at the southeastern part of Europe, the same logic, also the data from 2013, you can see that there's the annual consumption is around 30 BCM, domestically produced, thanks to especially Romania, approximately half of it. So this region needs to import approximately 15 BCM. It was in 2013, and it doesn't include prospective fields in the Black Sea, both in Romania and in Bulgaria. Then we have our neighbor. These are updated numbers for 2014, which shows that Ukraine consumes 43 BCM, produced domestically 20 BCM, so they need to import 22. So as Stefan said, with the reverse flow capacity of 20 BCM from Europe, Ukraine is almost there, so to say. But the big unknown is, of course, how the Ukrainian consumption will evolve vis-à-vis the conflict in the eastern part of the country, where the most heavy consumers of gas are located. And the second is how the production in Ukraine will evolve over the time. Combined picture of these three regions shows that this South and Central Europe consumes slightly more than 110 BCM, and only 1/3 is produced domestically, which means that this region, including Ukraine, needs to import at least 70 BCM. And Velké Kapušany, this is the entry gate for today, especially for the Russian gas to Europe. This is the first compressor station on the Slovak territory, and actually the biggest one in European Union, with the installed power close to 300 megawatts. And I will tell you later why this point is so important. Because we are in a hardware section, and the topic is Energy Union, I think Energy Union for us as a TSO is important from two angles or two perspectives. One is security of supply, and second is the price of the gas. Security of supply is a nice thing that everyone wants to have, but no one wants to pay for. From TSO's perspective, it's a combination of having more physical hardware, that means more pipelines, and potentially more sources of the gas. These are the results of kind of stress tests made by NSOG, and you can see that if you are a region which is physically dependent only on one route, then it's not a good situation, and you are too dependent on it. It's a situation in Southeastern Europe. You can see those countries marked in red, and they are dependent only on a single pipeline. So the risk of the interruption is huge for them. They don't have any alternative if there is a disruption upstream, somewhere in the upstream part. Second picture shows that it is always better to have more sources of the gas than only one. And if you look at the map, similar picture, the worst situation is in Southeastern Europe, because Southeastern Europe is not only dependent only on single pipeline or single corridor, but they are also dependent on the single source of gas, which is definitely not a good news. And that's why I believe that the proposed Energy Union, if there is a place in Europe where it should work, it is right here. And this is why we are here, and this is why I'm presenting the Eastring Project. This is some map showing the sources of the gas for Europe with some more numbers. I think we've had a lot of discussion yesterday regarding Norwegian gas, indigenous production, and also the future potential gas sources in this, from alternative sources, which are mainly Azerbaijan. And after theoretically lifting the sanctions on Iran, the whole region opens up for Europe. Iraq, Iran, and the Caspian gas, Kazakhstan, Turkmenistan, and so on. So that's why we believe that the day will come that this gas will come to Europe. It's not a question if, but when. Of course, it will take some time, but these countries have, if you look at the proven reserves of those 5 countries combined, their proved reserves are twice as large as the Russia has. These countries, not all these countries have access to the sea, so that they can export it as LNG. And those countries are not technically, so to say, well developed. So the first thing they will do, if they have the opportunity, is that they will export oil and gas in order to get some revenue. So I believe that this gas, these huge reserves, will come to Europe sooner or later, and they will come. And there are only two ways. One is across Turkey, and the other is under the Black Sea. Current situation is in Central and Eastern Europe and also in Southeastern Europe is like this. The discussions around energy union was started or triggered by two facts. One was the escalation in the Ukraine and the risk of the transit disruption in Ukraine. And the second was the announcement of Gazprom that they are canceling South Stream, which means that especially the southeastern part of Europe was in a really bad situation. If you look at this map, you can see that through Ukraine you have two corridors. We call it Northern Ukrainian Corridor and Southern Ukrainian Corridor. The northern one, which then continues to Slovakia, then Czech Republic and Austria, and then westwards to Germany and down to Italy, has a capacity 80 to 90 BCM in the direction from east to west. And after 2009 crisis, we learned our lesson. We made, together with colleagues in Austria and Czech Republic, lots of adjustments on our system, and now the systems are fully reversible, which is proved by the physical reverse to Ukraine. This system can supply actually physically 35 to 40 BCM from west to the east, technically, and the capacity can and will be increased. Then you have the southern part, or southern route in Ukraine, which crosses Moldova, Romania, Bulgaria, down to Turkey. This pipeline is used approximately by 50% for sending gas to Turkey, and the other 50% for supplying southeastern markets. I mean, Romania, Bulgaria, Greece, and so on. And now we have a situation that Russia, desperately trying to bypass Ukraine, proposed South Stream. It was cancelled. Now they are proposing Turkish Stream, and we can discuss it during Q&A, but I'm convinced then the Turkish Stream, definitely one pipeline will be built, maybe two of them, because Gazprom already has the pipelines in Varna, and both Saipem ships are docked in Burgas in Bulgaria. So definitely first string with a capacity of 16 BCM will be built, and most probably the second string will be built as well. The reason is obvious. The Turkish Stream will enable Gazprom bypass Ukraine, at least with the 16 BCM, which are destined to Turkey. It makes commercial sense for Gazprom, but poses additional threat for the Balkan countries because they will lose their gas transit. And they will lose, at the end of the day, also the revenues, and they will end up with the empty pipelines in Romania and Bulgaria as well. So what we propose is a project which is called Eastring. It serves multiple purposes because we are still talking about security of supply. We believe that this project, because it will have at the initial stage capacity of 20 BCM and will be connected to the Slovak system and then westwards, it will provide the all southeastern Europe with the additional capacity of 20 BCM. And in terms of security of supply, if you recall that the whole southeastern Europe consumes or needs to import 12 BCM, then the N-1 criteria will be fulfilled with a huge reserve margin. So this pipeline would provide all Balkan countries together with their interconnectors, with Serbia, with Greece, and so on, with alternative route. And they will not be dependent only on single pipeline. They will have the option to access the Western markets. So it will provide them with the possibility to access liquid Western hubs in Baumgarten, in Germany, and theoretically even in Italy and further west. Second reason why this pipeline can make sense is that if you look at the Turkish gas prices, they are still, the day-ahead prices are 2, 3, 4 euros above the Austrian prices. The majority of the Turkish gas consumption is situated around Istanbul. The Turkey has almost no winter flexibility because they don't have underground storages. So you can read, if you read the Heren or Argus reports, Every other day you can read that on Turkish markets they are curtailing electricity production from gas and ordering the private producers to switch fuels and so on and so on. You read it all the time. So ironically, this pipeline could also serve both the big Western shippers, maybe even Norway, and also the Turkish consumers, and send the gas from Western Europe to Turkey for some time. And of course, once this pipeline is in place, it can represent the highway for the Caspian gas to the Europe, because it will be built as a bidirectional. Let it be Azerbaijan, Iran, Iraq, Turkmenistan, Kazakhstan. So this pipeline could meet all these criteria at once, which is always better when you have more reasons why to build the pipeline. As Stefan said, it's sometimes very difficult to find a commercial logic on a new project. But when you combine it with providing security of supply to the Balkan countries, with alternative source of the gas for the Balkan countries, theoretically route to supply Turkey, and at the same time with the possibility to have the highway for the future sending gas from Caspian Sea to Western Europe, we believe that this is the most logical solution. We have set up working groups with our colleagues in Hungary, Romania, and Bulgaria. So we made several basic routing options. We made all the hydraulic calculations. So these are actually two basic scenarios which are being developed now. One is connecting Velké Kapušany actually either through Hungary with a new pipeline or through Ukraine via existing pipeline. Both possibilities have pros and cons, but these are two possibilities how to connect Slovakia with Romania. And Romania to build the new pipeline to the border point Isaccea, and then utilize the existing transit assets, both in Romania and in Bulgaria, because this pipeline, in 2 years' time, after Turkish Stream is built, will remain physically empty. And it provides additional incentive for the TSOs in those countries to connect it to the Eastring pipeline. Other option is routing, which we call B. This is the direct connection between Slovakia and Turkish Bulgarian border close to Malkoklar, which is the existing border metering station between Bulgaria and Turkey. And actually it's very close to Istanbul. If you look at the length, the A option is slightly shorter, the newly built pipeline, something like 800 kilometers. Option B is 1,000 kilometers. So just to wrap it up, Eastring would be a new pipeline, not to build with involvement of any specific shipper. It will be the pipeline built by the TSOs. It will provide the Southeastern Europe with alternative route, with access to alternative gas sources. At the same time, it will provide Western shippers with the possibility to supply those markets and even supply Turkey. And at the same time, it will be the corridor ready to transport the gas from whatever the alternative source of the gas can be. It will, as I said, it will come through Turkey, so it will be ready for transport the gas in the future. And of course, it will provide the TSOs in the respective countries, starting in Czech Republic, Slovakia, Hungary, Romania, Bulgaria, with possibility of utilizing their existing assets. Last slide for those of you who are technicians. This is a close-up view of the, as I said, on a biggest compressor station in Velké Kapušany. It's the beginning of our transmission system. It's at the border with Ukraine. It was built in 70s. During the 90s, it was completely refurbished, so we have new Rolls-Royce and GE machines there. Starting 2014, it was adapted so that it is now sending the gas also to Ukraine, the 15 BCM. And it has enough compression power, as I said, close to 300 megawatts only in this one compressor stations. We have 3 more in Slovakia. And this is enough power then for sending gas from Slovakia through Hungary, Romania, Bulgaria, down to Turkish border. If we build 1400 millimeters, 100 bar pipeline, it can be fueled only by existing compressors in Velké Kapušany. So you don't need to build any new compressor station along the pipeline, and you will be able to send slightly more than 21 BCM down to the southeastern Europe. So that's all from my side. Thank you.